Hello everyone. In this lecture, we will study the flowchart of the different phases of the compiler in short. In this diagram, we'll understand how this complete phases of the compiler are being explained. So let's understand translation of an assignment statement. So basically, you are given a code. You have a high level language code. So I have picked one of the statement of the given code. That is position is equal to initial plus rate multiplied by 60. So when this high level language code is being passed into the first phase of the compiler, that is lexical analyzer, it will be broken into stream of tokens that we have already understood. So this is just a brief summary and the complete flowchart of your compiler. So we are not discussing in detail what will happen in the different phases because we have already studied everything in the previous video. Okay. So this is the high level language code, one of the statement I have picked from that code, and this is being passed to the very first phase of the compiler, that is lexical analyzer, right? Now, the output of the lexical analyzer will be the stream of tokens. So this position, initial and rate have been stored in identifiers in the symbol table, and every particular symbol in this statement is converted into a token, right? So these are the stream of tokens stored in angular brackets. Then these tokens will be the input to the second phase of the compiler, that is syntax analyzer. Now, what syntax analyzer will do? Syntax analyzer is also called as scanner, or you can also called it as parsing. So here, it will convert these stream of tokens into a syntax tree. And in the syntax tree, we have already studied that it is a tree-like structure in which the internal nodes are your operators. That is assignment operator, addition operator, and multiplication operator. And your leaf nodes are your operands or identifiers or numbers. So you can see this is identifiers, these three are identifiers, and this is a number. So the information related to your identifier is also stored in the symbol table initially when we start, the first phase. Now the output of the syntax analyzer was this parse tree, which is now the input of your third phase of the compiler, that is semantics analyzer. Now, what is the difference between these two phases? These two have similar tree-like structure, right? It is also a syntax tree. This is also a syntax tree. But what is the basic difference? This is just a syntax tree, but this is a syntax tree associated with meaning, right? And what is the meaning associated with it? We consider that ID1, ID2, and ID3 are identifiers of type float. So we'll convert this 60, integer value into float value. With the help of the function into float. Now this 60 will no more be an integer value, but it will be converted to a float value. So we have associated the meaning to it so that there is because we take care of typecasting in case of your semantic analyzer. So that is why we have done this so that there is no loss of information. Then the SDT, that is syntax directed translation. This tree means your syntax tree with meaning is the input to the fourth phase of the compiler, that is intermediate code generator. Now let's understand how to write the intermediate code. As you can see in this particular syntax tree, the operator which is at the bottom of the tree is having the highest priority. So in this, the multiplication is having the highest priority, then the second highest priority is of addition, and the third priority is of assignment operator. So first of all, in this fourth phase, intermediate code generation, we will have, the use of temporary variables. So intermediate results will be stored in the temporary variables. So here, when I have converted this 60 integer value to a float value, this value will be now stored in a temporary variable t1. So basically this means this is t1, right? This information is stored in t1. Then id3 will be now multiplied with what? T1, because now it is being stored in T1. ID3 multiplied with T1. This value will be stored in a new temporary variable, that is T2. So now this part is evaluated and stored in T2, right? Now ID2 is added with T2. You can see ID2 is added with T2. So this complete result is then stored in a new temporary variable, that is T3. So this whole is T3, right? And then finally this T3 will be assigned to ID1. So for writing the syntax tree in intermediate code form, we have four assignment equations. Now this will be passed as an input to the fifth phase of the compiler, that is code optimizer. This phase of the compiler is the only phase of the compiler which is optional, right? So what it tries to do, it is trying to reduce the space and time complexity of the given code so that your particular code can be more efficient, right? So here you can see there are four statements that has been converted to two statements. So the number of steps have been reduced. So the number of temporary variables here were three, and here the temporary variable used is one. So the space complexity has been reduced, and because the number of statements have been reduced, so the time complexity is also reduced, because now it will take less time to process these statements. Now, what we can do is, instead of this is explicitly converting 60 into float value by using the function, but we can implicitly by using the function, but we can also simply directly write 60 as 60.0 and can multiply it with id3 instead of doing using this and calling this function. So id3 will be multiplied with 60 and the result will be directly stored to t1. Now what it has done, it has now multiplied this added this t1, this t1 has been added, right? This thing has been reduced. Now this t1 operation is not required. id3 is not multiplied with t1 but directly with 60.0. So then what we will do, we stored this information, this was stored in t2, now this information is stored in t1, and then T2 was added to ID2, but now T1 will be added to ID2, and it will not be stored in T3, but it will be directly assigned to ID1. So we can see that if we have to actually study the code, and if it is possible to somehow reduce it, we can reduce it by using the different optimization techniques. Now this reduced code or optimized code is the input to the code generator, and let's understand how it is going to write it into assembly language. So actually this code generation is not applied on the fifth this these two assignments, but on this four assignments, right? First is, it is loading this id3 value into a register r2. So basically in code generation we will be using the concept of registers. We know that registers are very limited in memory, so we have to very carefully use the registers. So id3 is this id3 value is actually a value which is now stored in a register R2. So with the command load f, LD means load and f is float. So the float value of ID3 is loaded into a register R2. Fine. After loading it, what we will do? We will multiply this R2 value with R3. Right? No, not this. But here there is a mistake. You have to write R2 only, not R3. This is not R2. So R2 is multiplied with 60 directly, and this result is further stored in R2 only, means in the same register only. And we have used hash before this because we are we are directly using this value in the given place instead of fetching the value. In R, if in register R2, if some value is stored, first of all we need to fetch it. Okay. So then we have another instruction, load float value. So again, what we will do, see here what we have done, we will now load the id2 value to the register r1. Fine. And after loading it, then we will add what, r1 with r2, because r2 is storing the result of this r2 multiplied with 60. So this multiplication result is ready, and it is now added to r1 whose value was just loaded. So and this result will be finally stored in r1 only, and then the stored value, then we will use this store command, and f is basically representing the float value. So this r1 value will be now stored in the identifier 1, right? So this was the code generation phase. So if this question comes in your exam, you have to actually make this diagram because it will be mentioned in the question that you have to draw the flow chart of the given phases of the compiler. So this was all about this video. In the next video, we'll study the importance of lexical analyzer. Till then, stay tuned. Thank you so much.